Um, you mentioned earlier LayerCake, and you actually said in a recent panel that the industry needs to focus on building trustless bridges and not making trusted bridges safer. And I think that's a really powerful quote. So, with this in mind, I'd love for you to highlight the main benefits of LayerCake over, say, traditional bridging protocols like multi-sig wallets and whatnot.
Yeah, look, okay, so basically you have a multi-sig bridge, you have an MPC bridge. MPC is not vastly different from multi-sig. Basically, this is a set of entities, people or companies, that are responsible for signing your value across chains. As we've seen time and time again, these entities and the sets of these entities generally hasn't been vast. I actually don't think there's any, the model of making, whether you have 9 entities that are part of the multisig or 100, it's still a multisig. It really doesn't make any difference. So obviously we've seen a lot of problems with these. We've seen them get hacked. We've seen there being social ways for a hacker to get into those entities and control those validators that are making the signatures, or I'd actually call them nodes. They're not really validators. And multi-sig bridges are, they're an early idea as to how to do things with a modicum of decentralization. But the reality is a multi-sig bridge can basically not be decentralized. I also think there's bigger problems with multi-sig bridges from a legal perspective, but I probably won't go into that. So basically, trusted bridges, we've spent, vast amount of our time thinking, how do we not build trusted bridges? So F-assets is an example of trying to remove the trust from a bridge for a non-smart contract tokens. Complexity of non-smart contract tokens is you can't use a smart contract, so you can't have complex logic on that side of the bridge. You can have complex logic on Flare, but you can't have complex logic on, say, XRP or Bitcoin. That makes it hard to actually make the bridge work. So the F-asset model is sort of exists to overcome that. And LayerCake is a trustless bridge for smart contract platforms. So this means we can be sort of more efficient with capital when it comes to LayerCake. It means we can do have different ways of managing that bridge. And so the way LayerCake works is essentially it uses this concept called bandwidth provision, which is an entity puts in, let's say, $100. And that entity is allowed to bridge $100 and only up to $100 in some period of time. And the period of time we're generally specifying is what we call the rollback period, which is a time over which we think that any fork of the network will resolve. It's important to account for the rollback period, because if you have a chain rollback during a bridging event, you can potentially lose collateral from the underlying contract that holds the deposited tokens. So LayerCake essentially has this relatively very sort of capital efficient way of using capital to secure the bridge whilst the bridging event is happening. This is something that we have termed insurance, meaning that essentially your funds are secured whilst they're crossing the bridge by this bandwidth collateral. And that's really important. And then I think we're really proud of LayerCake because it's trustless. And it's very, very hard to do a trustless bridge for smart contract platforms. In fact, most people give up, and that's why they've gone with multi-sigs. So we're proud of it being trustless. But I think, as we all know in this industry, just being decentralized, just being trustless, just having good tech that stays true to the ideals of crypto or blockchain just isn't sufficient to be successful. So LayerCake has this amazing, feature that we think is going to be incredibly useful, which allows people as they bridge. So when you deposit your tokens into the bridge contract, you can also specify pool data to go with those tokens. And what that means is that you're not just bridging from chain A to chain B, you can potentially be bridging from chain A into a dApp on chain B, executing within that dApp. You don't have to cover the gas fees. You don't have to cover the protocol tokens. That's all wrapped up in the fee that the bridge will charge you. So it's essentially an extremely fast and convenient way to be able to get your token from chain A to a dApp on chain B. Potentially, depending on how you structure the call data, you can bridge straight back just from that single transaction. So it basically allows people to execute transactions across chain without ever leaving their source chain. So if you're on Flare, you'll be able to execute potentially across many different chains without ever leaving Flare, just with one bridging transaction. And we think that in addition to the bridge being trustless, in addition to what we think is a novel and elegant way to structure a bridge, we think it brings utility to the bridging space that doesn't exist and is very useful and cool.
Yeah, I mean, the proof is in the pudding. I think there's a lot to look forward to with LayerCake, and it's one of the things that I'm particularly looking forward to. And the idea of being able to execute these transactions after it's been bridged, it's something that I saw Philip do in the recent LayerCake demo. Very powerful stuff, and especially when it comes to things like arbitrage, there's definitely opportunities there, and I'd be very intrigued to see what kind of dApps come from this.
Okay, hello. Thanks for attending this. I'm Philip. I come from Flare Labs. And today I'm going to show you how Flare Labs developed a LayerCake. This is a new insured-in-transit bridge that essentially works on all EVM chains and is able to transport ERC20 tokens efficiently, both capital efficient and both quickly, while still preserving this thing that Flare really fights for, the decentralization and not having to trust anyone except maybe the code and the validators that run it. Okay, so the title we had is a bit long, and also the description is a bit long, but we really wanted to emphasize that we're not only bridging something to a new chain, we're not only minting an NFT that is able to process some DeFi stuff, we're doing all this in a single transaction. So what LayerCake enables you, it enables you to move funds from one chain to another, add additional data, and execute something else on the next stage. So without ever having to interact with the secondary chain, without ever having to even gas on the secondary chain, you're able to move this, execute, use this data, and then do something more. So effectively, we're connecting the blockchains in a way that has never been seen before. So, okay, let's just quickly cover the agenda and see what we're going to take a look at. So firstly, we have a big problem. So cross-chain connectivity problem, we all know bridges are good, we use them, they're fine, everybody uses them, even your grandmother, although it might be a bit problematic teaching her how to really open this thing here, open this thing there, sign it correctly, and then wait for a soft confirmation, then wait for a little while so that it is confirmed for the second time, and all these ergonomics can be problematic. But even more, the security of the bridges is in question. It was in question a month ago, it was in question previous week, so we know that there is still something that we need to do there. And secondly, what we can do, we can use the bridges to connect different chains, and LayerCake is a good solution here, providing you with the ability to bridge both tokens and the data directly. And then we'll see the demo, how this can be done, how we can provide liquidity to another chain, how we can use the liquidity on another chain to enrich the first chain, use this trustlessly, efficiently, and then if the time permits, we'll do some hacking and see exactly how easy is it to use this and how quickly both the networks can process this data. Okay, so what's the problem? Let's take a look at a really simple problem. You're watching the news, and the only thing that's coming at you is some danger. There's inflation, you got a bunch of tokens locked, and maybe it's even worse. You have a dApp, you have a DAO treasury that's got a bunch of tokens locked, and because you can't use them, because they're on a network, when you can't really tap into all the liquidity, tap into all the available things that are there, you're effectively losing money, not just for yourself, but also for somebody else. So what are you going to do? Well, you want to do something, you want to make those tokens work for you and even for somebody else. So what you can do, well, you want to bridge them to somewhere else. You want to use these tokens in either another protocol or in another chain. So, and to do this, you can use an existing bridge, but we've all learned that bridges can be slow. I've seen bridges operated by human operators, and boy, was I not happy. I've seen bridges that were quickly exploited, and if you were maybe on a talk yesterday or 2 days ago, what have we learned from ECC 2020? Bridge hack was the most possible word you could guess if you were to guess an answer. So bridges are prone to be exploited. Bridges are most of the bridges that work are usually centralized. They don't really provide much value. They are not collateralized enough. So we have a bunch of bridges that should be secured by stake, but we've been seeing that this stake is not covering enough of the bridge data, or if we get to a bridge that's supposedly working, it's hiding beneath some sort of a multisig, and the multisig works perfectly until we have a black swan event and we see that it's not working perfectly because of some sort of a distant probability that something might get wrong. So using bridges currently is problematic, both from a security perspective and also considering all the developer ergonomics. So you have wrap ETH on Polygon, you want to wrap it somehow, you want to transfer it to, I don't know, to Cosmos, you want to transfer it back to Polygon, and you have all these prefixes, wrap Cosmos, Polygon, ETH, and to really use it in some sort of a transaction, you either need to have a swap and first do a swap, or you really need to go all the other way around and properly unwrap it, thus costing you both money and time to properly process those bridges. So what we want to do, well, we have already developed the LayerCake, and what LayerCake does, LayerCake essentially taps into the possibility of EVM machines to more efficiently bridge the data. So this is a kind of rough approximation, rough diagram of how LayerCake works. It's essentially there are essentially two practically similar contracts on each network, connecting the network and bridging ERC20 tokens. And what's making it work are those bandwidth providers in the middle that are immediately executing the transactions that people are requesting. So I, as a user, I start on the left, for example, on Flare, deposit some ERC20 tokens into the LayerCake bridge, thus emitting an event, and now the bandwidth providers compete to fulfill this bridging. Once they relay the tokens on the other side, they get a piece of the cake, they get some cut, and that's it. I never have to worry, how are they relaying it? Are they partially fulfilling it? Are they fully fulfilling it? And furthermore, I can also add some data up to it. What that means that I can say, okay, I'm sending 100 wrapped Ethereum from Flare to Sepolia or from Flare to Ether, and once it arrives there, I want to do something with it atomically. It's not I'm wrapping some ETH, I'm transferring it over, waiting for a few minutes, and then hoping that the arbitrage opportunity is still there. I'm doing this immediately executing an arbitrage, immediately swapping something, immediately depositing them, and if that fails, the whole transaction fails, and I can simply withdraw them in the beginning. And to make all this work from a security perspective, each bandwidth provider can bridge up to his bandwidth of tokens per specific amount of time. So this bandwidth gets refreshed so we can have an efficient bridge, but the length of this refreshment period is essentially controlled by how quick the network is and how often the network reorganizes. So if we have a network that is practically never reorganizing, we can have the bandwidth refresh very often. That means that bridge operators, the bandwidth providers, can essentially bridge huge amounts of data with only a small stake. If we have a network that has a problematic reorganizations capabilities, we might be forced to enlarge this data. But most of the time, we can do this pretty efficiently, and they only get paid in the collateral, in the tokens themselves. So what that means from a user perspective, we're abstracting away what's happening on the network. So you're starting your dApp with a user on the left that has no idea what's actually happening on Ethereum, for example. They don't need to have the gas tokens for Ethereum. They don't even need to have a proper setup wallet on Ethereum. You're paying for this using just the LayerCake bridge in the native tokens. That's abstracting quite a bit of different networks away. Okay, so what are we going to do? How are we going to solve the problem of having a debt treasury with too much tokens and not enough use for them? Well, we can use LayerCake to start on Flare, transport the tokens to Ethereum chain, where there is a bit more liquidity, swap the tokens to some sort of a Uniswap pair, then deposit them into a Uniswap V2 pool, and thus start minting some transaction, thus start minting the fees for swapping the things on Uniswap. Once we do this, we've essentially completed the first leg of our transfer. So the tokens, they're still ours, we still can control them, but they're somewhere else doing some work. And this has all been done using the LayerCake as an intermediary. And once we're finished, we can again instruct the LayerCake, this time really abusing the ability of LayerCake to transfer data over. We push the data over, requesting the withdrawal of those tokens. We provide, I don't know, a password, we provide additional data for unlocking, and the receiving contract on the other end withdraws this liquidity from Uniswap, swaps it back to the Wrap Ethereum, and then transports it back to Flare when we get hopefully a bit more of the original tokens without ever touching the second chain. And we can extend this, we can compose those things practically in an unlimited fashion. So we might be able to then provide a bit of liquidity from Ethereum to Polygon, to somewhere else, and then gather them all at the same time and push them back. Okay, so let's see the demo. I'm just gonna re-mirror this. Okay, so this is the dApp that's going to facilitate our demo. So as said before, we're going to start on Constant 2, so this is a test net for Flare, and we're going to bridge our tokens over to Sepolia. We're going to deposit them to a Uniswap V2 pool, and that's it. From then on, we hope that Uniswap will do the job instead of us. Okay, so what we need to do, we need to select the tokens, just, I don't know, token 4 and token 7. And we need to select the amount of tokens we wish to transfer to the other chain. Well, we can either select the specific amount of tokens in the native currency, but it's usually easier for user to select it in dollars. It's easier to approximate stuff in dollars. So what we can do, we can just say, okay, I'm going to transfer, I don't know, $1,000 of Ethereum. And the question is, how much Ethereum do I have to transfer for $1,000? Well, to properly do this, our dApp will need to query some sort of an external exchange, external oracle. But if you're on Flare, as you initially start, you can directly tap into the Flare's FTSO system, which is a native oracle ingrained directly into the network. So you can just instruct the smart contract in your dApp to read directly from Flare's decentralized oracle, thus limiting the possibility of having this value hacked or having this value manipulated by some external actor. So you're totally bypassing anything external. You're just saying, look, smart contract, I want to transfer this amount, calculate all these directly on chain. Okay, once we have this, we just need to deposit it. And the deposit is pretty much a simple transaction on Flare. So we sign this, the smart contract here will instruct the layer, will deposit some amount of funds to the LayerCake, and provide additional data. We sign this, and what we now need to do, we need to check what's happening, and the easiest way to do this is to check on Explorer. So what we see here, so we executed a transaction, start liquidity farming, and if we check it a bit more thoroughly, we can see that what the transaction really did, it transported a bit of wrapped Ethereum, so the thing we wanted to transport, firstly to LayerCake, and then secondly, the LayerCake decreased the amount by some and send it to the dead address as a source of a fee. So once we have this, the LayerCake essentially starts working. So we've emitted, so we're here on the first step. We've emitted a deposit, and now this is getting bridged, and the receiver contract will soon start processing this. So how do we know that the receiver contract is processing this? Well, we again can check the block explorer on the other side, and I guess I'm limited. And we can see that some standard operations from 39 seconds ago were being executed. So immediately after the event was emitted on the Flare side, LayerCake bandwidth providers picked up the event and started transporting it to the other side. And if we check the contract that is receiving this on this step, we can see that, just a second, we can see that we got a bunch of transactions and a bunch of tokens transferred to this one. Okay, so, and what does this mean? Well, this actually means that we're now proud owners of 2 new tokens on Uniswap v2 on the contract we own on the other side. And to really properly account who's the owner of this, well, we mint a DeFi NFT indicating that this piece of liquidity, this small piece of liquidity, corresponds to our address. Why NFT? Well, with NFT, we can control who the owner of the liquidity is, and we can easily say, look, this NFT can be traded, this NFT can be loaned, we can take a deposit on it, we can loan it to somebody else, or we can totally transfer it. And when we're going to execute the second leg of this transaction, the funds will get deposited to whoever the current owner of the NFT is. Okay, so this is now, so we have this now in the Uniswap v2 pool, and when we're ready, we just need to start the second leg of the transaction. Start on Flare layer, input password to the LayerCake, and initiate a transaction that requests withdrawal. So what we do now, we start with LayerCake, we just push over some information, not really a value transfer, but this information transfer, again, interacts with our receiver contract, and the contract is able to properly interpret it, get the data from Uniswap pool, remove the liquidity, get the data from the NFT, and in the same transaction, that's important, in an atomic way, again instruct the LayerCake, but this time in the other direction, to start processing and to start moving all these tokens that were removed from the liquidity pool and swapped back to the original chain. So with one transaction on Flare, we initiate the beginning of liquidity removal and thus instruct the LayerCake to essentially move the funds twice, first time starting on Flare and then removing the full tokens back. Okay. So we're just going to withdraw this. Again, we sign this on Flare, so we're never really interacting with anything on Ethereum. All this is done by the LayerCake bandwidth providers. All the gas fees on the other side are paid by the bandwidth providers, and also the security is such that we can always see how much the bandwidth providers are holding the residual bandwidth. Okay, and that's it. So the LayerCake has, the transaction has gone into the other direction. We now hold no tokens on the other side, and the tokens are now being moved by the LayerCake to the Flare side. Let's just check another thing. So one important thing when considering protocols like this is the security and the availability of the data and how you can really utilize this. And if we check here, this is a dashboard we use to quickly and efficiently check what's happening with our protocol. We can see that both on the destination, on the origin, and on the destination, we've had those 2 big value transfers. So we can easily see what the bandwidth providers are doing and how their bandwidth is being depleted. So we only made a small transaction, so the bandwidth has not depleted, but you can see that ours is much bigger than the bots we are running to keep the LayerCake alive and to see if everything is going on. Okay, so that's mostly it. So this is a simple demo dApp. It's currently running live on Sepolia and Coston 2, so both test networks. The code is open source. It's available on Flare Labs repository. And what essentially means is that we can already start building quick and efficient dApps that are utilizing this bridge to transfer both value and data. So this allows you not only to say, okay, I'm going to bridge this amount of value and stay there as a dead chain. This allows you to bridge the amount of value and request that this value immediately enters into a computation, immediately enters into something really bigger and can be changed. So let's say I bridge something to Ethereum, I compose it with another bridge from Ethereum to Polygon, I compose it with a bridge from Polygon to Cosmos, and I can immediately close the loop, make an arbitrage, and do all this atomically. So if somewhere something goes wrong, I haven't lost my tokens, they're not locked, I can just simply withdraw them back from the LayerCake. All this in a trusted environment, without trusting anyone, without having a multi-sig and relying on somebody not getting hacked, somebody not losing their keys, and without having to really having trust into some central third party. Okay, so that's it for the demo. And since the thing is live and this is a workshop, I think it makes, how much time do we have? 10 minutes. Okay, so since it's a workshop, it makes sense to at least show how to utilize the LayerCake really, really quickly and pretty much efficiently. So here's a QR code you can scan. We have a GitHub repository prepared so you can play around. And I'm just gonna open this into my Visual Studio Code and make a really, really simple transaction. So to just quickly show you how LayerCake operates, we've seen in Explorer that we've had a bunch of store and execute transactions. So those are effectively bandwidth providers communicating with the LayerCake. By storing a transaction, you instruct the LayerCake to emit an event. By executing a transaction, the bandwidth provider effectively signs that the emittance and the minting of new tokens is signed by the bandwidth provider. It is guaranteed by the bandwidth provider up to the bandwidth and allows them to effectively execute the second leg of the bridge. And all this is made by all this is effectively controlled by this big struct that has some initial data and some metadata related to the bandwidth provider. And each bandwidth provider effectively also provides an ECDSH signature guaranteeing that the execution of this LayerCake operation is signed by them. So the security level of executing a transaction is exactly the same as the security level of the Ethereum transaction. So there's no middle ground with transaction being valid on LayerCake but not being valid on Ethereum. It's secured by the same cryptographic protocol. Okay, so let's just quickly try to transfer a bunch of funds from my Cost2 account to my Sepolia account. Okay, can you hear me now? Can you just turn the mic a bit? So, hey, 1, 2. So, see, yeah, it's pretty easy to use this. Even the co-pilot can do it. So we're just going to disable it for a while. Okay, so where do we start? So essentially what we need to do, we need to first get our address. It's pretty standard. So Flare and Sepolia, they're both EVM compatible chains. That means that all the existing tooling that exists can be reused. So you don't need to explore some new language. You don't need to get acquainted to a new tooling. You just download Hardhat. You just use the existing Web3 libraries. You just use existing Ethers libraries, and there you are. So no specific things. So what you need to do? Well, firstly, you need to get LayerCake. Let's see where this config resides. So we get LayerCake, and we need to get token to approve it and to request the token to be sent. Const token. Just to make sure this is correct. Okay, let's check. And Cost2. Okay, so we got our token. Now we only need to approve it. We need to approve it to the LayerCake address. And for some amount, let's say for, I don't know, 30 rep teeth, or maybe for 3. And now the hard part comes on. So how do we instruct the LayerCake to do this? Well, we could manually create all this struct, but we already provide you with the library that essentially abstract all this away, and you only need to provide some initial values. So let's see where this is. It's in the helpers. So we have a function called prepare simple transfer when you only provide it with all the required data. So how much you're sending, what's the fee, who you're sending to, who you are and who you're sending to, and maybe data if you want to execute something on the other chain, but that's it. So all the other stuff gets calculated automatically. So you don't have to work out how to make this happen. Okay, let's go back. So we just need to get the operations. Okay, let's import this. So we need to get an amount. Let's say we're going to send 1 ETH. We're going to send a minimal fee. Sender would be me. And I'll also be sending to me because that's the easiest way. Let's just convert this to big number so that it does not complain. And that's it. So we have these full operations already prepared, and what we now need to do, we just need to instruct the LayerCake. And from there on, everything is automatic. Let's just tx.tx and see what happens. It's taking a while to do this over that network. Okay, so we got our transaction, and that's it. So if we, again, check this transaction in Explorer, we can see that in that case, we've transported 1 wrapped Ethereum, we paid some fee, and if we went back onto the to our address on another chain, it's going to that one. If we check our address on another chain and wait for a while for the Sepolia to mint this, we would see that we would get this newly minted wrapped Ethereum to our address directly there. Okay, that's mostly it.
Mission Control, we have liftoff.